So children, now moving to the worksheet number 3A. First question, three masses M1, M2 and M3 are connected by light string and are pulled as shown in the figure. You're asked to find the tension T1 as well as T2. So we have already solved these type of numericals. Here in this end, the force F is being applied. So first of all, let us try to calculate the acceleration of the three block system. So clearly we know that the acceleration of the three blocks is the net force, that is F net upon the total mass. Hence, A is equals to the total force applied on the system is F upon, what is the total mass, children? Total mass is M1 plus M2 plus M3. That's it. So this is the value of your acceleration, but you're asked to find out the tension T1 as well as T2. If you observe the picture carefully, because of this tension in the string, the mass M1 is being pulled. Hence, the value of tension T1 can be equals to this tension. This tension is a type of force applied on mass M1 and is being pulled with some acceleration A. So this force equals to mH, or T1 is equals to mass is M1, acceleration is A. This can also be written as M1 times of, what is the value of A? Just now we calculated as F by M1 plus M2 plus M3. So the result will be M1F plus M1 plus M2 plus M3 is the value of T1. So this is the value of T1. Now let us also find the value of T2. So this force tension, because of this, these two masses together are pulled towards the right side. So what is the total mass that is being pulled, children? The total mass is M1 as well as M2. Hence the value of T2 is equals to M1 plus M2 into A. Or this can be written as M1 plus M2 into the value of A is F upon M1 plus M2 plus M3. Hence, you are asked to find the value of tensions T1 and T2. The value of T1 is found to be M1F by M1 plus M2 plus M3, and the value of T2 is found to be M1 plus M2 into F upon M1 plus M2 plus M3. Is that okay, children? So now moving to the next question. So second numerical, a mass of block M1 is resting on a smooth table. This is a smooth table on which a block of mass M1 is being kept. This is connected to a mass M2 through a light pulley. This is a light pulley, okay, through a light string upon a pulley as shown in the figure. Find the tensions in the string and thrust on the pulley. So thrust is again a new concept for us. Thrust is nothing but the total net or resultant force acting on the system. That's it. So the resultant force acting on the system is the resultant tension acting on the pulley itself is called as the thrust of that. Well, so let us calculate the thrust later on. First of all, let us try to find the value of tension in the string. So before finding up the tension in the string, first of all let us try to find the acceleration of the system. So if you observe the mass M1, its weight itself is acting downwards and the normal reaction acting upwards, and this normal reaction is balanced by the weight of the body. So the only unbalanced force acting on the system is the tension T. So this tension T is acting rightwards. As a result, the mass is being pulled. So with what force it is being pulled, children? T. So from that we can say that, writing the equations we have, T must be equals to this tension force is pulling this block M1 equals to M1 times of A. T is equals to how much? M1A. Now let us have a look about this. So this tension is acting upwards, whereas the weight of the body M2G is acting downwards. Well, the body is accelerated downwards according to the figure. Okay, as it is accelerated downwards, the downward weight is greater than the upward force. So what is the downward force? M2G is greater than the tension T. So writing the equation of motion for this, we have M2G net force is equals to higher force minus lower force. M2G minus 2T is equals to M2G. So let us try solving both the equations. So plus T and minus T will get cancelled. So then you are left with M2G is equals to M1 plus M2 into A. M1A plus M2A, I have taken A as common, then you are left with M1 plus M2 into A. So bringing this M1 plus M2 the other side, we have M2G by M1 plus M2 is the value of acceleration. So the acceleration of the system is found to be how much, children? With what acceleration the bodies are in motion? It is equals to M2G by M1 plus M2. But in the numerical, you are not asked to find the acceleration of the system. You are asked to find the tension and also the resultant tension or thrust acting on the pulley. So substituting the value of A either in equation 1 or equation 2. So equation 1 is easier. So substituting the value of equation A in equation 1. Okay. So substituting the value of A in equation 1. So what is that, children? T must be equals to M1 times of the value of A is written as M2G upon M1 plus M2. So the tension in the system, whether here or here, along the pulley, along the string, the tension acting in the throughout the system is found to be M1 M2G by M1 plus M2. Now let us try to find out the thrust. Thrust is nothing but the resultant tension acting on the pulley. Children, we know that these two tensions, if you look at the picture, the tension on this pulley, this tension is in this direction and the other tension is in this direction. So it's very clear from the figure that both the tensions are acting perpendicular to each other. The two tensions are acting perpendicular to each other. If the tensions are acting perpendicular to each other, then the angle between them is equals to 90 degrees. So with the help in the concept of vectors, you already learned that if two vectors are acting perpendicular, then the resultant is given by root over, okay, two vectors, if you consider the two vectors as P and Q acting at an angle of 90 degrees direction. This is Q and here it is P. Okay, Q direction and P direction. Two vectors are acting at an angle 90 degrees. Then the resultant is given by P square plus Q square plus 2PQ cos theta. Theta is now 90 degrees, but we know the cos 90 value is 0. So cos 90 0 means the total term will be 0. 2PQ into cos 90 is 0. So 2PQ into 0 is 0. Then you are left with R is equals to root over P square plus Q square. What is that equals to? R is equals to root over P square plus Q square. Suppose if the other case, suppose if P equals to Q. If P is equals to Q, then what happens? We can write R can be written as, in terms of P, I write it as P square is, instead of Q also let me write it as P square. Then this will be root over 2P square. Hence the resultant is found to be root over 2P square is root 2 into P. Okay. So it's very clear that if two vectors, if two equal vectors acting perpendicular to each other, then the resultant is given by root 2 times of that given vector. So here also if you observe, these two tensions are acting perpendicular to each other. So no doubt the resultant would be now. So what is the resultant, children? So therefore the resultant or the upthrust acting, thrust. So thrust, instead of resultant I'll be writing it as thrust. Okay, thrust or the resultant force or whatever you find, I'll write it like this. Thrust is nothing but root 2 times of tension T. Okay, so instead of vector we have replaced the force vector, that is tension vector. So it is nothing but root 2 times of T. So F thrust is equals to root 2 times of, the value of T is how much, children? M1 M2 G by M1 plus M2. So root 2 M1 M2 G by M1 plus M2. This is the thrust acting on the pulley. So the total net resultant force acting on the pulley is root 2 times of M1 M2 G by M1 plus M2. I hope this is clear, children. So I'll be moving to the next numerical, that is numerical number 3. So two bodies of masses M1 and M2 are connected by a light string passing over a light pulley as shown in the figure. Then you are asked to find the tension in the string and again the thrust on the pulley. Okay, so first of all, the similar to the previous model, first of all let us write the equations of motion, then we can go with the, we will find the value of acceleration and then tension and then finally the thrust. Okay, so if let us imagine the free body diagram for the first case. So this case, if you observe the free body diagram, this is M1, upward force is tension T, downward force is mass M, so force means M1G, weight of the body, and this is accelerating upwards. Okay, so based on that, if you write the equations of motion, then as it is accelerating upwards, the resultant equation will be T minus M1G must be equals to M1A. T minus M1G equals to M1A. Now coming to the right part. So again, if you observe, let us drop the free body diagram for M2. So let us imagine this as M2 whose weight M2G is acting downwards and the tension T is acting upwards. Clearly it was given that this mass is accelerating downwards. So based on the relation, we can write the equation of motion. So clearly, as it is accelerating downwards, the equation of motion can be written as downward force minus upward force is the net force. So mass into acceleration of the second body. That's it. So let us try solving the two cases. So we know that plus T and minus T gets cancelled. So we are left with the positive value is M2G minus negative value is M1G is equals to M1A plus M2A, or M2 minus M1 times of G is equals to M1 plus M2 times of A. So clearly bringing this M1 plus M2 to the other side, we have M2 minus M1 upon M1 plus M2 times of G is the value of A. So this is already we have discussed in the explaining the concept of the pulley. So the acceleration of the system is M2 minus M1 upon M1 plus M2 into G. So if you substitute the value of acceleration either of the equations, that is first equation or second equation, we can get the value of T. So let us try to substitute the value of A in equation 1. So substituting the value of A in equation 1. So where is equation 1? Let this be equation 1 and this be equation 2. So this value in equation 1, let us see what happens. T minus M1G is equals to M1 times of A. Instead of A, what should I replace, children? I should replace it as M2 minus M1 by M1 plus M2 into G. You will get 2M1 M2 by M1 plus M2. We have already solved in while explaining the concept. So T can be be written as, carry this minus m1g the other side, then it will become m1g plus m1j, and this total term plus this g, I'll bring it down. Instead of writing this g, I'm keeping here. So m1g into m2 minus m1 upon m1 plus m2. That's it, children. So in both the terms, you have m1g as common. So taking the m1g as common, then you are left with m1g into m1g is removed. So what is left here? 1. So plus this m1g is removed. So what are you left with? m2 minus m1 by m1 plus m2. So solving this, we get the value of t as, cross multiply, children, m1g into, take the LCM in brackets, m1 plus m2 plus m2 minus m1 whole upon m1 plus m2. So solving this, minus m1 and plus m1 gets cancelled. Then you are left with m2 plus m2 is 2m2. 2m2 into m1g is how much, children? How much is that? 2m2 into m1 is 2 m1 m2g upon m1 plus m2. Hence, we found the value of t as, 2 m1 m2g by m1 plus m2. So this is the first thing they have asked for. What is the tension in the created in the string? Its value is 2 times of m1 m2 g by m1 plus m2. Simply the same concept whatever we have discussed. Okay. So, but one thing, another, they have also asked us to find the thrust acting on the system. So clearly if you observe that this tension is acting upwards and here also the tension is acting upwards. So these two tensions acting on the pulley are parallel to each other. So parallel means angle between the two tensions is 0 degrees. Okay, so if cos 0 value is 1, that's it. So you know that the resultant is equals to root over t square plus 2t into t is 2t square cos 0 degrees. Cos 0 is 1. So 1, if I replace, this will become 2t square plus 2t square, that is equals to t square plus t square plus t square, 2t square is 4t square is nothing but 2t. So what is the resultant, children? The resultant thrust acting on the system is equals to 2 times of t. When angle between the two vectors is 0 degrees, then the resultant is equals to sum of the two vectors. Okay, what are the sum of the two vectors? This is t plus t, that is 2t. So that is the thrust acting on the pulley. So that is, what is thrust means? The total force that is acted on the pulley. So what is the total force, children? 2t. So these are the two results which we need to find out. Okay, so now moving to the next question, question number 4. A system consists of 3 bodies of different masses. So what are the 3 masses? m1, m2 and m3 are in contact as shown in the figure. A force F is applied to a mass m1. So they given here as F and here they gave it as T1. So F is nothing but T1 applied on a mass m1 as shown in the figure. So find the contact force between m1 and m2. So what is the contact force between m1 and m2, children? It is T2. The contact force between m1 and m2. So this is between m1 and m2, the contact force is T2. So it asks you to find out T2, and also between m2 and m3. So this is m2 and m3, contact force between m2 and m3 indicated with T3. So you are asked to find the value of T1, T2 as well as T3. Okay, whereas the force was given as T1. So I hope the question is clear, children. So let us try substituting the equation. So before that, let us try to draw the free body diagrams. So where shall we start with? First of all, we'll go with the third mass here, m3. So the system is not at all accelerating anywhere. Simply the system is being balanced up. So if you consider the third case, so this m3 if you consider, let us draw the free body diagram for M3. So this is your M3 whose weight must be acting downwards and tension must be acting upwards. Okay, so what is the tension, children? T3 is the tension upwards. So observing this, we can see that the upward force must be balanced by the downward force. The system is not accelerating. Okay, so clearly from the figure we can write that T3 is equals to M3G. So what is the contact force between M2 and M3? Its value is T3, which is equals to how much, children? M3G. That's it. So this part is over. Now let us move to the next part. So what is the next part? So M2. So let us focus on M2. So here it is M2. The weight of the M2 is no doubt acting downwards. M2 weight is acting downwards. Okay. Along with that, tension is also acting downwards. How much tension? T3. So along with that, tension T3 is also, two downward forces are acting. One is weight of the system as well as the tension in the string. What are the upward forces, children? Identify the upward forces. The upward force here is only one force, that is T2. So here it is T2. So from the figure, we can clearly say that the upward force is balanced by the downward force. Hence, T2 must be equals to T3 plus M2G. Okay, T2 is equals to T3 plus M2G. But what is the value of T3? Just now we calculated it as M3G. So this is M3G plus M2G. Rearranging the terms, we can find the value of T2 as, take out G as common, then you are left with M2 plus M3 into G. The value of tension is M2 plus M3 into G. Okay, so these are the things you are asked to find out, T2 as well as T3. So T2 is found to be M2 plus M3 into G, whereas T3 you found as M3G. Children, even though they haven't asked us, let us also try to find out the value of T1. Okay, for your understanding. Well, so this, let us focus on this. So your answer is done, but let us try to find the value of T1 as well. Okay, so identify this first, children. M1. So this mass, let us write it as M1, whose weight no doubt acting downwards and upward force is nothing but tension T1. But if you observe this carefully, along with the weight of M1G of the body, one more force is acting downwards, that is nothing but your tension T2. So both T2 as well as M1G, weight of the body, are acting downwards, whereas the upward force is only T1. So along with weight, we have T2 downwards. So now writing the equations, we have upward force must be equals to downward force. So T1 must be equals to T2 plus M1G. That's it. Or the value of T1 can be written as, what is the value of T2? Just now we calculated as M2 plus M3 times of G along with here M1G. So all together we have G as common, hence T1 is equals to, if you take G common and rearranging the terms, first of all let me write it as M1, then M2 and then M3. Take out common as G. So the value of T1, the force applied, is given as T1 equals to M1 plus M2 plus M3 times of G. So these are the results you are asked for. Okay, children? Well.